Hello, everybody, and welcome to this lecture that kicks off the academic year for us at CSER, the Center for the Study of Existential Risk. I'm Sonia Amadei. I'm the director of CSER, and today it is my very great pleasure to welcome our speaker, Professor Lorraine Daston. Professor Daston is Director Emeriti at the Max Planck Institute for the History of Science in Berlin, and visiting professor in the Committee on Social Thought at the University of Chicago. She's been one of the most influential voices in shaping how we think about rationality, not only in science, but across many domains. Her work ranges widely. She has written on wonder, objectivity, the moral authority of nature, and probability theory, as well as Cold War rationality and scientific modernity. And we all remember, your legendary book with Peter Gallison on objectivity. That was, I guess, a huge step at the beginning of your career. More recently, Professor Daston has turned her attention to the history of rules in her new book, Rules, A Short History of What We Live By in 2022, and to the ways scientists have learned to work together across borders in Rivals, How Scientists Learned to Cooperate in 2023. Her current project, Thinking with Natural Disasters, builds on her 2024 Terry Lectures at Yale. Professor Daston's many contributions have been recognized with some of the highest honors in the field, including twice winning the Pfizer Prize, the Sarton Medal of History of Science Society, the Dan David Prize, and the Gerda Henkel Foundation Prize. Professor Daston is also a professor at the American Academy of the Arts and Sciences, a member of the American Philosophical Society, and a corresponding member of the British Academy. So please join me in giving Professor Lorraine Daston a great welcome.
Thank you so much. Sonia, thank you so much for that gracious introduction. It's always a pleasure and an honor to be speaking in Cambridge. Thank all of you for coming. This talk, although it's way out of period for me, I'm an early modernist by training and by proclivity, returns me to where I started my scholarly career with a dissertation on the history of probability theory, and in particular, a history of probability theory applied to insurance. This talk is very preliminary, and I wish to express my thanks to the archivists of the Swiss Reinsurance company, who very kindly and very generously allowed me access to at least some of their records. Every 50 years ago, there's a natural disaster of such devastating proportions, and it happens in a wealthy, fully insured part of the world, that even the world's biggest insurance companies face enormous claims that threaten their very existence. This was the case, for example, with the San Francisco earthquake of 1906, after which a score of insurance companies went bankrupt and many others teetered on the brink of ruin. It's also the case with Hurricane Betsy in 1965. Hurricane Betsy was a Category 4 storm that ravaged southern Florida, the Bahamas, and southern Louisiana. It became the first Atlantic storm to cause what was by then an astronomical sum of $1 billion in damages, as well as taking 81 lives. These are the moments when badly shaken insurance executives question the fundamentals of their business. What exactly is an insurable risk? How much risk is too much, even for those masters of disasters, the world's leading reinsurance companies? Now, very few of us will have had direct dealings with reinsurance companies, so let me explain where they fit the grand pyramid of insurance. When we buy home insurance or life insurance or fire insurance, we are dealing for the most part with primary insurers. These insurers, in turn, hedge their bets by taking out policies with the reinsurers. And the reinsurers sometimes, if the risk is great enough, will hedge their bets by taking out still further policies with their colleagues in other reinsurance companies. It's called retrocession. So imagine now a kind of pyramid of insurance, and at the very pinnacle are the world's largest reinsurance companies, Munich Re, founded in 1880, and Swiss Re, founded in 1863. The principle of all of this tier upon tier of insurance and reinsurance is very simple. You don't want to put your eggs in one basket. So you try to spread the risk as thinly as you possibly can. So ideally, the strategy of risk distribution protects all the insurers from ruinous losses if a mega disaster like Hurricane Betsy or the San Francisco earthquake occurs. Practically, if disaster does strike, reinsurers will have to pay up, especially the gigantic ones like the Zurich-based Swiss Re or the Munich-based Munich Re. These are moments of crisis for the insurance industry, and the deliberations of the Swiss Re Board of Directors briefly becomes at such moments a kind of philosophical seminar on the nature of risk in a dangerously uncertain world. But unlike most philosophical seminars, this one has potentially huge world consequences. So let's listen in on their discussions over the course of a roughly 40-year period, roughly from Hurricane Betsy in 1965 to Hurricane Andrew in 1992, when Swiss Re began to realize that something was happening to the weather. This is the Swiss Re gleaming glass headquarters on the Müttenquai in Zurich. Throughout the 1970s and the 1980s, the executives of Swiss Reinsurance began to note a very alarming trend. The number and severity of weather-related disasters worldwide was steadily climbing, along with the sums paid out in insurance claims. Already in the 1970s, Swiss Re had actually gone public with its worries about anthropogenic climate change. Long before the meteorologists had reached a consensus on this fact, the insurance companies knew. By 1985, a commission of some of the world's leading reinsurers set up a commission to study weather and earthquake risks, and they began to fear that climate change-related weather patterns might soon prove more disastrous than earthquakes or volcanic eruptions. Swiss Re executives were in an excellent position to register such trends. These big reinsurers, like Swiss Re, have to build up enormous reserves in order to cover such big losses, which makes them amongst the world's biggest investors, a theme to which I'll return in a minute. And they're also among the world's best informed monitors of all the terrible losses of life and property happening in the world, or at least the wealthy part of the world. If you do not have an insurance policy, you do not exist for the reinsurance companies. The buck stops with Swiss Re. If an earthquake levels Los Angeles, a wildfire ravages Spain, Swiss Re would have to pay out. So when Hurricane Betsy devastated heavily insured parts of the Bahamas and the southern United States, even Swiss Re's immense capital reserves were hit very hard. At a grim meeting in October 1966, the company's executives took stock of the damages. Betsy was responsible for the worst losses in the company's 100-year history. And to make a dismal situation worse, the stock market was in a slump, so there was no easy possibility of recouping their losses with investments. Their investments had fallen far short of what was needed to rebalance the books. This is one of those moments when one of the world's biggest insurers doubted the wisdom of insuring any natural disaster whatsoever. And there's very good reason for Swiss Re to be wary of insuring natural catastrophes like hurricanes or earthquakes. So unlike life or fire insurance, these kinds of risks are called cumulative. So when you die, is probably going to be independent under ordinary circumstances of when your neighbor dies. That means that the risks are independent. However, if an earthquake or a typhoon or some other disaster strikes your neighborhood, whole sections of a city may be mowed down, and not only will one have to pay the primary insurance premiums for, let us say, earthquake damages, as in the case of the 1906 San Francisco earthquake, there were even worse secondary fire damages and, of course, life insurance claims. Where a disaster might strike was just as uncertain as when. Even in rock-solid Switzerland, earthquakes could not be ruled out. It's astonishing to me how often the Basel earthquake of 1356 turned up in the minutes of the Swiss Re Board of Directors, even once the explosion of Vesuvius in 79 CE. No place was safe, ever. Moreover, the losses wrought by such a catastrophe were cumulative, as I just pointed out. So calculating the possible losses could be almost as tricky as calculating the probability of such an event. So the two data points that every actuary needs to be able to start setting a reasonable premium are, first, what's the probability of the event, and what are the losses that would be incurred should such an event occur. In the case of natural disasters, you have usually neither of these two data points. Finally, it was almost impossible to build up reserves for a once-in-a-century catastrophe, if only because taxes and inflation would inexorably gnaw away at the investment. So no wonder some of the Swiss Re executives after Betsy thought it was time to brace the public with a kind of psychological preparation for the likelihood that sooner or later catastrophic risks would exceed the capacities of the global insurance industry. This was in 1966. Since then, catastrophic risks, especially those related to climate change, have mushroomed beyond the imaginings of even the gloomiest Swiss Re executive. And yet, market competition and government pressure pushed even the hyper-cautious Swiss Re executives nonetheless to accept risks that made their actuaries blanch. If London insurers, like Lloyd's, were willing to stomach earthquake coverage to make home and fire insurance more attractive, how could Swiss Re afford to lag behind? And if the governor of Florida threatened to exclude Swiss Re from all insurance dealings in that state, if it didn't offer hurricane insurance to these repetitively flooded areas, how could Swiss Re retreat from such an otherwise profitable market? Discussions in the Swiss Re boardroom seesawed back and forth between the position that insurance for catastrophic risk was impossible and the retort that any risk was insurable as long as the premium was high enough, and in any case necessary if Swiss Re was to maintain its leading position in the world insurance market. So the actuaries had their marching orders. Somehow, the risks of hurricanes, cyclones, floods, tsunamis, wildfires, heat waves, and ever more frequent natural disasters, and the losses they cause would have to be quantified so that realistic but still competitive premiums could be set and adequate financial reserves built up. Now, the insurance industry had long been in the business of covering damages caused by catastrophic weather, not always on a sound statistical basis. Some of the earliest such policies against hailstorms were issued in the late 18th century when there was absolutely no statistical basis for them. By 1911, however, Lloyd's of London was offering a so-called pluvious policy, you can still get this, that compensated organizers of a wedding or a garden party, a cricket match, or other outdoor event in case rain spoiled the party. There were even sunshine deficiency policies for travelers in case blue skies clouded over on your Mediterranean holiday. But by the 20th century, even those boutique policies were being firmly anchored in statistics when the London-based Eagle Star Insurance Company, for example, began to offer such a pluvious policy in 1920. An underwriter with the splendidly Dickensian name of Mr. Gambles undertook the Herculean task of examining and tabulating over 4 million records from the Met Office, from which he sought to ascertain the pure loss cost per day of granting rainfall insurance in every district of the British Isles. So the problem that the actuaries faced was not lack of data. There was plenty of data on past weather and weather-related disasters. Their problem was that they could no longer safely assume what all statistical inductions must assume, namely that the future will be like the past, that it's safe to extrapolate from those 4 million records gathered by the Met Office over almost a century to what's going to happen in the next 20 to 30 years. By the 1980s at latest, insurance companies were acutely aware that the frequency and intensity of hurricanes, cyclones, typhoons, floods, and other weather disasters were rising steeply. And so were the damage claims filed with insurance companies, not only because the weather had become ever more savage, it had become more savage, but also because of demographic trends. Ever more people were living in more densely populated areas. There's a predictable demographic transition in which about a fourth of a country's population moves to its capital city. For London and Paris, this happened by 1700. It was happening in places like Athens or Cairo by the 1970s. In such cases, you start to have very heavy losses simply because of the number of people and the number of buildings involved. So the actuaries did try to gather data. They mapped areas of highest losses. This is from Munich Re, trying to figure out where the most people died. They also compiled lists of disasters by locale. This is also from Munich Re, and they compiled lists of damages and deaths. They were also early adopters of computers. They called for international cooperation among insurers to create shared data banks. They even sent researchers into archives to find records of past disasters to extend their statistical baseline. At one point, Munich Re was advertising for medievalists to come comb the records of medieval annals in order to see if there was any pattern to earthquakes. But by the mid-1980s, some Swiss Re actuaries had abandoned all hope of obtaining reliable statistics on either the probability of weather disasters or the amount of resulting damages, and they were instead experimenting with a new technique called loss scenarios, which could, at least in the words of one of their actuaries, provide something of a well-founded intuition about the company's exposure. So what a loss scenario is, you imagine a 7.2 on the Richter scale earthquake in central Los Angeles, and you try to compute what the damages would be. You still have no idea what the probability of this event is, and you also start to vary the probability. This becomes a lot easier once you have the computing power of a new generation of computers in the 1980s, but it's still all guesswork. Despite all of these ingenious modeling techniques, the actuaries could not shake their fear that such disasters were intrinsically uninsurable as the effects of climate change became ever more obvious. At a 1972 meeting of experts convened by UNESCO to discuss the statistics of natural disasters and their consequences, the actuaries despaired of applying standard methods of statistical inference, and they also ruled out the possibility of using more subjective Bayesian estimates of probabilities. They threw cold water on extreme value analyses of the sort that were being tried out by the Swiss Re actuaries. None of these methods yielded reliable extrapolations from the past to the future. And you can see here that the losses are mounting. So the earthquake losses actually, with the exception, of course, of the 2011 earthquake and tsunami in Japan, were relatively minor compared to the kinds of losses that the insurance companies were having to pay out for weather-related disasters. Man-made disasters were also proportionately trivial compared to those weather disasters. So despite the warnings of the doomsayers, Swiss Re's coverage expanded throughout the latter half of the 20th century. So you see here, this is a company which starts very much concentrated in Europe, and by the end of the 20th century, the beginning of the 21st century, they have expanded onto almost every continent of the globe. Unsurprisingly, this vast liability made Swiss Re executives into the most nervous of nervous Nellies. The minutes of their meetings in the 1950s, the 1960s, the 1970s read like the transcript of a group therapy session for anxiety neurosis. So in the 1950s, they shudder over the mounting claims for car accidents, and they try to persuade their countrymen to return to bicycles. In the 1960s, they fret over how the increased technological rationalization of heavy industry made factories more expensive to build, like this brewery in Cleveland, and therefore more expensive to compensate if they burn down. When the first Boeing 747 landed in London Heathrow in 1970, they despaired. They cursed those new jets introduced by Boeing as diabolical engines because it increased air traffic in expensive planes, meaning more accidents and higher claims. Swiss Re executives never tired of preaching that an ounce of prevention is worth a pound of cure. They worry that the mere fact that a homeowner takes out an insurance policy may lead to negligence in terms of essential building code requirements. Their minds were always racing to the worst case scenario. As the Cold War heated up in the late 1950s, the Swiss Re executives actually contemplated moving their headquarters to a safer place. They thought they were fairly confident that if World War III broke out, it was going to break out in Europe. So at first they considered the United States, but then they thought, the next war is probably going to be an atomic war, and the missiles will be aimed at the United States. What about Canada? No. It was in the Soviet missile flight path, too close to the United States. After the Arab-Israeli War broke out in 1967, they consider exiting the highly profitable Israeli life insurance market. A visit by one of their executives to South Africa leads them to cancel all insurance in Soweto for fear of riots. Headlines about riots in Los Angeles, floods in Hamburg, wars in the Middle East, triggered fits of jitters in the placid boardroom in Zurich. So until the 1980s, the very idea of expanding insurance coverage against natural disasters made the Swiss Re executives reach for their smelling salts. When claims from Hurricane Betsy decimated the company's reserves in 1966, some Swiss Re executives thought it was high time to stop insuring such disasters. Now, more venturesome members of the board of directors countered that such catastrophic risks could be insured. It was all a question of charging high enough premiums. But how high? Nobody could say. That was supposed to be a matter determined by actuarial statistics scrupulously gathered and analyzed for each specific risk and locale. Earthquakes in California, hurricanes in Florida, terrorism in Algeria, airplane crashes everywhere. Since mathematically based life insurance was first offered in the late 18th century, the insurance industry had made its sturdy actuarial foundations the basis for drawing a bright line between the foresighted prudence of taking out an insurance policy and wastrel gambling in taverns or speculations on the stock market. In the view of Swiss Re and other insurance companies, the highly moralized difference between selling and buying insurance and selling and buying stocks, both in essence bets on uncertain outcomes, was that insurance was based on solid statistics. Yet starting in the 1990s, the famously risk-averse Swiss Re executives began actively courting risk. They start putting out brochures like this one, or this one. Each of these brochures features an arresting title photo of the devastation wrought by some natural catastrophe. They're aimed both at the primary insurers and their customers, and they offer both fear. These risks were terrifyingly real and they were growing each year, but also hope. Insurance coverage was available to avert the total collapse of cities or even whole countries should disaster strike. Even more surprising, Swiss Re and other major reinsurers began to offer what came to be called catastrophe bonds. So you see here, so primary perils are, for example, the earthquake, and the secondary perils are, for example, the fires caused by a gas line exploding during the earthquake. And you can see that Swiss Re is insuring ever more of these starting in the 1990s. They insure almost nothing from about 1970 to about 1990. And then, depending, of course, on the year, this great spike here at 2005 is, of course, Hurricane Katrina. They begin to offer more and more such coverage. They also begin to issue a new financial instrument called a catastrophe bond. This may sound exotic, but if you have a pension fund, you are almost certainly involved in this. So what this is a bond that is bought by some quite wealthy investor. I think the price to play is at least $1 million, possibly more. So, but the pension funds have plenty of money to invest. And the investor and Swiss Re decide on a kind of package of risks. So in this case, for example, this is a hypothetical case, the chartreuse green, the spring green here, this is European windstorms here. This is this sort of multi-peril here, including US windstorms. And then you have California earthquake, I think is the blue, yes, right here, right. So, and depending on what happens in the next, so the bond is for 3 years, depending whether any one of these disasters actually strikes in the 3-year period, you either stand to make an extremely healthy profit, usually higher than what the market would have brought you, or you lose all your money. So if you're a historian of insurance, this sounds eerily familiar. This is the Finis Nauticum of Rome. So the Roman way of insuring long-distance commercial ventures was that a wealthy party, an investor, would bankroll a merchant ship to some lucrative locale, perhaps the grain stores, warehouses of Egypt. And if the ship came back with its cargo, then the investment plus a handsome amount of interest would be repaid. But if the ship was attacked by pirates or wrecked at sea, you lost your entire investment. That's essentially what the catastrophe bonds are. If you had been following the long history, especially the discussions amongst the Swiss Re executives, this is jaw-dropping. Suddenly, the nervous Nellies of Zurich have been turned into riverboat gamblers. So the question is, what happened sometime toward the end of 1980, the beginnings of the 1990s, to completely reverse their attitude toward insuring catastrophic risks? I was only allowed to look in the archives until 1990. But so what I'm about to give is somewhat speculative, but based on secondary sources and the actuarial literature, I think these factors must have played a role. There are at least two factors which seem to have played a decisive role. One was Swiss Re's leadership in creating insurance for nuclear reactors in Europe in the 1960s and 70s, which was another example of a risk entailing potentially vast damages and backed by no reliable statistics. And the second factor was the financialization of everything in the 1990s. If this reminds you of those derivatives made notorious by the 2008 financial crisis, that's not an accident. It's the same kind of packaging of many different elements into a single financial instrument. Both of these factors, I think, merit a closer look. I'll be very brief about both of them, but I'm sure many of you will be able to say more than I about each topic. So if there's one image that conjured up the greatest conceivable disaster in the collective imaginary of the latter part of the 20th century, it was probably an atomic bomb explosion. By the 1950s, the nightmarish associations of atomic energy with weaponry powerful enough to destroy all of human civilization had been cemented into the minds of the public worldwide by articles in the popular press about the deadly effects of bombardment and radioactive fallout in Hiroshima and Nagasaki, what-if novels, apocalyptic films. As the only country ever to have deployed such weapons upon human beings, the United States was particularly eager to counter such atomic nightmares with atomic dreams. More specifically, the dream of a potentially unlimited source of energy in the form of atomic and then later nuclear reactors. In December of 1953, then US President Dwight D. Eisenhower addressed the United Nations and announced a dramatic and rhetorically calculated shift in American nuclear policy. Although the United States already embarked on an atomic arms race with the Soviet Union, would continue research, development, and manufacture of atomic weapons, it would, Eisenhower revealed, now also support the creation of an International Atomic Energy Commission to oversee peaceful applications of atomic energy. Eisenhower's Atoms for Peace speech opposed visions of irenic atomic utopias to those of bellicose atomic dystopias. There was supposed to be flourishing agriculture, plentiful cheap energy, cures for diseases, and atomic-powered everything, versus those mushroom cloud explosions, devastation, and hideous suffering. The Atomic Energy Act of 1954, which expanded the powers of the Atomic Energy Commission in the United States, it had been initially created right after World War II as a government monopoly to make sure that fissionable materials were available for military use. It was expanded in 1954 to include the promotion and regulation of the private applications of atomic energy. There was only one catch. The private firms, like General Electric, in the United States and later in Europe, that the governments hoped would build atomic reactors to realize the promises of progress and prosperity, firmly refused to put so much as a big toe into such dangerous waters unless they were offered affordable liability insurance against accidents. And the insurance firms were even more adamant that they wanted nothing, absolutely nothing to do with atomic reactor insurance. The insurers had a point. Quite aside from the challenges of safely transporting radioactive materials and disposing of radioactive waste with half-lives longer than all of recorded human history, there was the fact that relevant engineering and scientific knowledge was changing by the week. Moreover, as those involved in hammering out guidelines for this new kind of insurance insisted time and time again, the implications extended to almost every other form of standard insurance, from life to fire to accident. A nuclear accident, for example, changed the very meaning of the word accident, since the slow, cumulative effects of radioactive contamination on both people and physical plant lacked the defining element of suddenness that ordinarily applied to such policies. And what would happen to shipping insurance if two vessels carrying fissionable material collided, or two nuclear submarines, for that matter? What health insurance for workers in atomic plants, not only reactors but also laboratories and hospitals working with radioisotopes, would cover conditions, for example, leukemia, that were diagnosed decades after exposure to radioactive sources? And the biggest headache of all, how could the premiums for liability insurance even be estimated, much less damages paid, without reserves that dwarfed anything even the reinsurance business had ever before contemplated? So no wonder their first reaction was exclusionary causes that banished all risks relating to atomic energy from their policies. This impasse was only overcome when the United States, and then later Europe, copying the American model, formed national pools of insurers who would cover, the initial figure was up to $60 million in the case of such an accident. And after that, the government would step in and cover the additional damages up to $500 million. This provided basically a safety net under the insurance firms by the government in order to encourage the building of nuclear, first atomic and then nuclear reactors. These numbers were snatched out of thin air. In the records of the congressional debate over why 500 million, they said, well, what's the average between 0 and infinity? And so they divided and got $500 million. This is the sort of things that makes the actuaries just tear out their hair. And there were simply no figures. There was a report commissioned by the Atomic Energy Commission from Brookhaven Laboratory and submitted to the US Congress. It estimated the property damages caused by such an accident, reactor accident, near a major city, this is in 1957, at US $7 billion, with 3,400 deaths and 43,000 injuries, with a probability of such an accident as 1 in a billion. But when the author of the report was pressed in congressional testimony, he said, Congressman, please, you shouldn't take these figures seriously. All that anyone could agree on was that the probability of such an accident was very small, but if it happened, the damages were going to be very big, and no one had any idea how much very small and very big were. So this is the kind of risk scenario that previously would have sent the ultra-cautious Swiss Re actuaries screaming from the room. And indeed, by their lights, it didn't even qualify as a risk. A risk is something that you can calculate the probability of, as opposed to radical uncertainty or danger. And for the actuaries, red lights were blinking on and off, danger, danger, danger. They wanted nothing to do with this. But by the 1980s, the Swiss Re executives were congratulating themselves on having pulled off both a financial and diplomatic coup. They were the ones who spearheaded the organization of the European insurance companies in pools that mimic those of the United States, which had been like herding cats. And moreover, they began drawing explicit analogies between reactor accidents and natural disasters. What the debate over atomic energy risks foreshadowed was a new way of thinking about catastrophes that blurred the line between the natural and the man-made and made all of them, even the most devastating, potentially insurable. So human culpability was certainly at stake with atomic reactors, both in their construction and in their maintenance. But in all other respects, the catastrophic reactor accident resembled an earthquake or a volcano. It was unpredictable, almost unimaginably destructive of life and property, and without any solid statistics. In the cases of both nuclear reactor accidents and natural disasters, the line between natural causes and human responsibility began to blur. And in both cases, there were only the most speculative estimates about frequency, intensity, and losses. The distinction between a quantifiable risk and radical uncertainty had begun to melt. The second factor, also contributing to erasing distinctions between the human and natural, as well as between statistically quantifiable risk and out-and-out bets, was the financialization of everything starting in the 1990s. So in the 1960s, the 1970s, the 1980s, if Swiss Re wanted to insure, let us say, an oil refinery in Libya, they would have sent out a team of engineers who would have crawled under the pipes, they would have kicked them, they would have looked for rust, they would have been doing what they called risk engineering, which is sort of on-site technical inspection about how well maintained this plant was. Those people all begin to be replaced in the 1990s by people who have degrees in mathematics, who have degrees in computer science, who have MBAs, who have training in finances. And they begin to develop a model of risk which is a kind of model of fungibility. As far as they're concerned, a major earthquake in a densely populated and highly insured area, more or less commensurable with the default of Lehman Brothers in the financial crisis of 2008. They begin to appoint a CAT peril team, a catastrophe peril team, to model all such catastrophes. And Swiss Re is perfectly in step with these developments in the financial markets. They're not the first people to come up with the idea of actually selling risks. That idea originates with the famously risk-seeking Chicago Board of Trade. I don't know whether any of you ever visited the Chicago Board of Trade in its heyday. It consisted of a kind of pit in the middle with a lot of guys in sneakers shouting at each other and gesticulating wildly. And the Chicago Board of Trade had the idea that, just as they'd been selling since the late 19th century, soybean futures, pork belly futures, they could sell risk futures, insurance policy futures. This idea did not take when it was first proposed in the 1990s. But by the early 2000s, the catastrophe bonds were showing extraordinary resilience and profitability. Despite the failure of these new modeling techniques to predict and prepare for a natural disaster of the magnitude of Hurricane Katrina in 2005, income from the sale of catastrophe bonds did cushion big insurance firms like Swiss Re from the kind of ruinous losses they'd suffered with Hurricane Betsy. Even more impressive, if you look at the performance. So what's really interesting here is that the catastrophe bonds can not only hold their own with index funds like Bloomberg, US corporate, other index funds, even when there's a major hurricane like Hurricane Ian, they recover extremely quickly and they almost never dip below the index fund. That means that there's a kind of diversification of risk, which is also very attractive to investors, which is it's very rare that a major natural catastrophe is going to coincide with a financial crisis, or at least so the reasoning. Catastrophe bonds come in all flavors, depending on the kind of risk being bundled together. As one hedge fund manager put it, I would like some Cal quake with a little Japanese wind. You can get a rough idea of their distribution here of what's being insured by category. All the parameters here are estimated, but they're minutely specified. So if it's, for a hurricane, it's a particular wind speed measured at a particular locale in order to count for a payout for the catastrophe bond. Whether a disaster in the cat bond package triggers a loss of a vested principal is, as I say, a matter that is minutely specified. And there are, of course, extremely sophisticated mathematical models that try to price the risk. The problem is that these mathematical models are sophisticated. They absolutely earn that adjective, but they're not necessarily accurate. There are specialized firms and insurance companies, of course, which are hoovering up vast amounts of data on the past frequency and intensity of the disaster in question by geographic region, so earthquakes, hurricanes, hailstorms, etc., and using these to try to estimate the probability of a future such event in the very short term. That's why the catastrophe bonds are only issued for a maximum of about 3 years. You can see here that, so the comparison of losses from recent hurricanes. And on the basis of both past data and computer simulations, the modelers then estimate losses depending on different scenarios. For example, the damage that a Category 4 versus a Category 5 hurricane would cause in Miami. The brute calculating power of modern computers makes it possible to model many such scenarios, varying both the probabilities and the loss estimates, so that you get basically a kind of envelope of possibilities. And then finally, you have additional models of the performance of the stock market over the lifetime of the catastrophe bond. As I said, these are rightly described as very sophisticated, but that does not ensure accuracy. Earthquake prediction has not been notably improved by harnessing big data. No model even pretends to cover the impact of climate change. This means that it's very difficult to reliably extrapolate from these data points to the future. Indeed, the more complex the model, the weaker its predictive power. I'm glad to talk more about this during the Q&A. Modeling potential losses does rest on firmer evidence, but all such models yield is an envelope of possible scenarios, each assigned a probability value that is more a guesstimate than an estimate. Yet quantifying without numbers has become profitable, at least in the very short term. It's time for me to conclude. Although reinsurance companies like Munich and Swiss Re operate on a much longer timescale than most businesses or governments, compared to the timescale of climate change, they are still creatures of the short term. Viewed through the narrow lens of the insurance companies, a geographically dispersed disaster unfolding in slow motion is no disaster, until it erupts into spectacular devastation right here, right now. By default, it falls to the state or to some international consortium of states to encompass risks that span centuries and continents. And in fact, the state is the shadowy presence in all disaster scenarios, regardless of whether they are attributed to nature, to humans, or to both. It's the state that is expected to foresee, plan for, and mitigate disasters into the ever more remote future. And it's the state that's expected to care for the victims and repair the damages when recourse to the law and insurance lies out of reach. You can imagine the predicament after the devastating California wildfires of last January, of homeowners who could no longer afford fire insurance in their neighborhoods. It has fallen to the state of California to be the insurer of last resort. The United States started a national flood insurance plan for just this problem, to help homeowners who lived in floodplains get some kind of insurance. But when they tried to at least proportionately increase the premiums of this heavily subsidized insurance just a little bit, it created furious protests on the part of the homeowners who were covered by these government policies, and even the most Tea Party-ish Republicans in Congress began clamoring for support. This program is bankrupting the government, but it is the government in the end which is expected, even in a quite libertarian political atmosphere, to be the insurer of last resort. Quite recently, the European Court of Human Rights found the government of Switzerland guilty of endangering the lives of its senior citizens, more specifically its senior female citizens, by failing to meet its commitments to lower CO2 emissions. Even mammoth reinsurers like Swiss Re, which insouciantly issue catastrophe bonds and manage astronomical sums, make it clear that they depend on the state to cover losses if a nuclear reactor accident or an earthquake lays waste to a densely populated and wealthy area. Now, some countries like Mexico have turned to their own catastrophe bonds, so-called sovereign catastrophe bonds, in an attempt to raise money should a major natural disaster strike their country. The problem is that the funds, and if they don't have enough funds, for example, to raise from taxes, these so-called sovereign cat bonds, however, do have one major weakness. They depend on the stability of the financial markets, the very markets that decimated state coffers with crippling debt after the 2008 financial crisis. Like other financial instruments, cat bonds are all but impossible for nation states to regulate. Many are insured by so-called captive companies in the low tax regions or the zero tax regions like Bermuda and the Cayman Islands. And the markets themselves are by definition international, so that one nation state cannot succeed in reining in the excesses in another jurisdiction. This leaves the nation state in the unenviable position of being asked to shoulder ever more responsibility for the welfare of their citizens as the risk of climate-related disasters rises, with ever less power to control globally either the forces responsible for climate change or the financial instruments that profit now from those rising risks. States have long justified their powers by their responsibility to offer their citizens security. At first, this was military security. But increasingly in the 20th century, this was security from want, from sickness and poverty in the form of social security. Each time state responsibilities have expanded, so have state powers. This is reassuring for some, it's alarming for others. In the 21st century, the state is being asked once again to expand its realm of responsibilities. Now, a new category of blame is beginning to coalesce: state failure. Failure to foresee, failure to forestall, failure to protect, failure to rescue, failure to repair. The powers that will be required to meet those new responsibilities are only beginning to be pondered. Or at very least, they are going to have to require a rethinking of the foreshortened timescales of democratic election cycles and the circumscribed geographic scale of the nation state. thank you very much for your attention.
All right, so we are going to now have some questions and answers, and we'll both sit up here, so go ahead and be comfortable.
Okay.
And I'll join you in a second. And we're going to have a microphone so that if you can wait for the microphone to come to you, then we'll all be able to hear you. Feel free to introduce yourself if you're comfortable doing so. And also to make a timekeeping announcement, we're going to go ahead and run over about 10 minutes or so. This clock is already a little ahead. And if for some reason you need to leave, then feel comfortable. We know that you might have another commitment or obligation. So with that, thank you very much. That was just, you covered so much material, and I'm sure that there are some burning questions in the audience. So would anybody like to lead off? I see a hand over here, so I'll go with this gentleman over. Yeah, you with the check shirt. Yeah, if we can.
Oh, thank you. That was really fascinating. I'm Alex from HPS here in Cambridge, and just starting at the Parker Library as a fellow at Corpus Christi. And I'm also an early modernist, but I found your data for 2023 very interesting, the table you had, because it seems to me that something happened in November 23 where cyber catastrophes are also starting to be insured. There was a little grey bar at the top. Yeah, and so I really liked how you said that in the transferal of thinking about atomic disasters to natural disasters, we might also, especially with the way that war is conducted nowadays, be seeing a transferal of that kind of thinking to cyber disasters, and we get a merger of the natural with the digital.
Right. Yeah. Thank you. I mean, I cannot say with any certainty whether or not the gnomes of Zurich are contemplating this, but it's an absolutely logical next step. And it really, I think, depends on their estimation of how short the short term is. So the one thing I think which these models really can help with is basically circumscribing the risk to a very short period. And the problem with cyber attacks now is that even in a very short period, one has to expect there's going to be a lot of them. It seems to me that this is something that's not quite yet ready for their catastrophe bond model. In order for the investment to pay off, so by the way, I mean, in 2024, the return on an investment for a catastrophe bond issued by Swiss Re was 19.7%. That's a really respectable return. But if they can't be confident of at least meeting the index fund following the market, they're very unlikely, I think, to take on a risk. But I absolutely agree with you. That is a logical next step.
Okay, great question. Let me see. I'm going to go with Maya in the middle. Yep. Go ahead.
Thank you so much, Professor Daston. This was amazing. So many questions, but I'll try to just ask one. My name is Maya, and I work at the Center for the Future of Intelligence, sister center to CSER. So my question is about climate scientists in all of this, and in the last 35 or 40 years, and what is their relationship with financial institutions, with insurers, and the kind of increasing sort of climate denial or skepticism, or the what is happening to science in all of this? Is it sort of like a data point? Is it data that is informing or being manipulated by insurers? Kind of like what is their relationship?
Insurers have sterling motives for believing the scientists. They really are interested in having the facts of the matter. I know that Munich Re employs geophysicists. I do not know whether or not either of those two gigantic reinsurance companies, Munich and Swiss Re, employ meteorologists or climatologists. I wouldn't be surprised if they did. But they completely understand the threat that climate change poses to their business model. So I was telling Sonia over lunch today, in the early 2000s, Allianz Insurance, which is another one of these mammoth insurance companies, gathered together a few of its comrades, the really gorillas of the reinsurance agency, and they banded together and they said, we are no longer going to offer insurance for coal mines. And if you do not have insurance for a coal mine, you cannot operate a coal mine. And this created a furore in the United States, quite predictably. Governors of Republican states with coal mines sued them for antitrust. This case, as far as I know, is still pending. But that just gives you an idea. These are people who not only believe the climate scientists, they are trying to act to accelerate measures to stop more CO2 being pumped into the atmosphere out of sheer self-interest.
Okay, so there was a question. Yes, can I go over on this edge to the person all the way?
Yeah, first of all, thank you very much for this amazing presentation. My name is Fernanda. I'm working at the Cambridge Center for Risk Studies, analyzing systemic risks and climate transition. And my question is around this point that you touched about how insurance is looking at how, okay, I can insure until a certain point if I elevate my premium. However, at the same part, the government interacting as one of the safety nets, but also how with a slight change of premium, there will be this social unrest, and therefore how that actually makes this system tricky, to say the least. So my question is, I know, for example, that if there is the case of the flooding, there might say, okay, so maybe to decrease the risk, what we can actually do is if you build a dam, then there can be maybe less damage, or it's less likely that the damage is going to be as high, so therefore the premium might be adjusted and still be something affordable. So my question is, have you looked or have you seen in general in the field how insurance is trying to deal with governments, for example, by saying if you're investing a bit in climate mitigation or climate adaptation, that might actually make the insurance affordable?
That's very interesting. I don't know of such cases, but that does not by any means mean that they don't exist. Certainly the insurance companies are extremely pro-precautionary measures. So this is commonsensical. Your premiums, for example, for earthquake insurance in Los Angeles are lower if you have taken the precautions, the building construction precautions that will not earthquake proof, but at least earthquake temper damages. So there already is a model in the case of earthquakes. And it would make absolute sense. I think there was a case in Germany, the flooding of the Elbe, fairly recently, in which the government, however, was the one that was proactive, maintaining dikes. And of course, the notorious case of Hurricane Katrina, in which it was the US Corps of Army Engineers, which was initially sued for their failure to maintain the levees in New Orleans, but then with the help of Dutch engineers, the people, the real masters of water, came and helped to repair. So there are these sort of government community insurance clusters, but how systematically they're pursued, I cannot say.
I think we have time for 2 more questions. Okay, I'll go to you toward the front, since you're so brave to be in the front to start with. Yeah. Oh, you're waiting for the microphone though. Hold on a second. It's on its way.
Hi, my name is Mylene. I actually live in Zurich, so it was really interesting to hear like all these new things because I obviously didn't know about that. What I was interested in is were these insurance companies the first to like actually did bigger research in climate change?
To the earlier question, yes, they are very interested in the research. And as I mentioned in passing, they are in some ways that were ahead of the climatologists. They had published already in the 1970s in German, so it didn't excite a great deal of attention, worldwide attention, their belief that no matter what the climatologists said, the weather was changing. on the basis of the loss claims, the mounting loss claims that were all accumulating on the desk of Swiss Re. They're very interested. Whether or not they're supporting it, whether or not they're employing climatologists, that is another question that I can't answer, but they're monitoring it very, very closely.
So while I'm going to wait, I'm going to send the microphone over here, but just to sneak in a little question, have they ever done anything to try to mitigate risk?
So you say to mitigate risk.
To try to get actors that are being insured to take steps that would.
Sure. I mean, as I said, you can lower your insurance by, for example, if you are in a flood zone, for example, you can raise your house. So many houses in New Orleans and in Houston and other areas which are quite regularly inundated by hurricanes have a sliding scale of insurance premiums, depending on what measures you've taken.
Fossil fuels, it's harder, right?
Well, this was their attempt with the coal mines, which got this savage fight back on the part of the Republican governors for an antitrust suit.
Why?
Yeah.
Okay, so we have, I think, our last question here.
Okay, I'll try to keep it very brief. My name is Amira. I'm a PhD student here in history, and I'm working on big data. So when you were mentioning complex models, my ears pricked up. And they pricked up even more when you said, well, the more complex the model, the less accurate the prediction. And I was wondering if you could elaborate both on the degree of complexity as well as how complexity might obscure representation within models, which might point back to Maya's question. Thank you.
Right, yes. So the more data you have from especially very heterogeneous sources of heterogeneous reliability, the more noise you are building into your model and the more uncertainty. So we're talking over lunch at problems, for example, that many models which are extremely good at retrofitting, because they can use an unlimited number of free parameters, are very bad at prediction. And in fact, you could almost argue that the more free parameters you add, the worse it's going to be at prediction because of the amount of noise which is built in.
All right. Do you guys have patience for one more? Should we probably, where's my event? Laura, do you think, is it time or what do you think? We have time for, Laura says we have time for one more question. All right, I'll go with this gentleman who's sitting right in front of me, and who needs the microphone then? It's been, oh, hold on a second.
Yes, please just shout.
We can probably wait a couple seconds. Hold on.
The science of attribution risk has really come on in the last decade. And almost every major event like Storm Daniel in the Mediterranean and such comes out in 6 months' time with an attribution saying that the previous probability of such an event is now 10 times or 100, sometimes 100 times due to climate change. Is it not possible to sort of tap into that science and give you a better estimate of the risk of future events? For instance, if the frequency of a previous 1 in 100 event is now 1 every 5 years, surely that gives you some sort of statistical basis for estimating the degree to which risk is rising.
Right. No, and I think that those are being used. The one problem is that, as I understand these attribution studies, I'm trying to remember the name of the very interesting scientist in London who does these, Federica, I cannot remember her last name, Flynn something. But as I understand it, these are very much tailored to the individual event. And that's why they're so important, because they're so carefully tailored to the individual event. This makes them difficult to extrapolate to other events in the kind of broad categories which are used by the insurance companies, like windstorm, as opposed to a particular kind of windstorm or wildfire in a particular locale. But they are changing. So in the 1980s, one of the real breakthroughs in earthquake insurance was a kind of micro mesh grid over locales that were earthquake prone, and then studying every little square in that grid, and then moderating the premiums accordingly. And very similar techniques are now being used for other kinds of natural catastrophes. And that, I think, really could feed into the models and sharpen their focus.
All right, with that, I think we do have to have our final round of applause. Professor Daston, thank you so much.
Thank you.